Okay, so I want to go over the solution to this percent yield problem. First of all, I want to point out a couple things about this. First of all, I'm starting with a balanced reaction, and below each of the chemicals, I'm giving the molar mass for that particular chemical. All right, so that will prevent you from having to take the time to calculate that yourself. All right, one of the chemicals in this reaction is a liquid at room temperature. And I'm providing the density for that right here. So this problem will be incorporating a lot of the things that we've done in stoichiometry. So the question that we have here is you mix 14.1 grams of calcium hydroxide, this chemical, with 6.82 milliliters of phosphoric acid, which is this right here. It says, first of all, what is the theoretical yield of calcium phosphate? That's right here. But then it says you're able to isolate 7.21 grams of calcium phosphate. What is the percent yield? Okay, so in any percent yield problem, the first thing that we have to do is figure out what the limiting reagent is. All right, and again, the limiting reagent is the chemical that runs out first when you mix these together. So to do this, I'm going to set up two crossbars to calculate the number of moles of each of these. Okay. So first of all, one of the things that we do whenever we have density information is that we turn that into a relationship, all right, so that we can take this 1.89 grams per milliliter, and we can just say that means you would have that many grams in 1 milliliter of H3PO4, all right. So we are given the amount, so I'm going to start with the amounts of calcium hydroxide right here. I'm going to convert that to moles by using its molar mass in this relationship right here. That gives me the moles of calcium hydroxide. With the phosphoric acid, we start with 6.82 milliliters of that. And first we need to turn that into grams, and we use the density information to do that. And then we can use the molar mass information to convert that to moles. All right. So at this point, we know how many moles of each of these we have. All right. And remember, we can't just look at the one that there's fewer of and assume that that's the limiting reagent. We have to consider how many moles of those we need from the balanced reaction, and basically to calculate what we call the reaction equivalence. All right, and you do that by dividing each by that coefficient. Okay, and so by taking the number of moles and dividing each by the coefficients that we have in the balanced reaction, we can come up with this number which we call reaction equivalence. All right, so if you have 0.19 moles of calcium hydroxide, you essentially have 0.0633 reaction equivalents because we need 3 of those. All right, and you'd have this many reaction equivalents of the phosphoric acid because we need 2 of those to get this reaction to occur. All right, so we can now just visually compare these two numbers. All right, and the one that has the fewest number of reaction equivalents is going to be the limiting reagent. All right, and so by looking at these two numbers, we can see here that this number right here is actually the smaller of the numbers, and that means that calcium hydroxide is our limiting reagent. All right, and if that's our limiting reagent, that means that this phosphoric acid is our excess reagent, which means it's the thing that after the reaction occurs, you would actually expect to have some of that left over. All right, but again, the thing that runs out first is what controls how much we could make. All right, so we won't actually need this anymore. All right, so what we're going to do now is say, well, based on the fact that this is our limiting reagent, how much of our product could we make? So setting up the next crossbar, this is where you say, okay, if this is the thing that runs out first, all right, if we have, we're going to try to figure out how many grams of our product we could make, all right? So we're going to start this with the number of moles of calcium hydroxide. Remember, you're starting it with the moles of calcium hydroxide, not the number of reaction equivalents that you would have from that, all right? So starting from that number of moles, all right, then we're going to give the mole-to-mole ratio between calcium hydroxide in calcium phosphate. And remember, that comes from the balanced reaction. For every 3 moles of this thing right here, we should be only able to make 1 mole of this material right here. And then we use the molar mass relationship right there to convert that into grams of calcium phosphate. So you'd have this little crossbar right here. Okay, and that would give you 19.6 grams of calcium phosphate. All right, one thing I want to point out is just to make sure that you're paying attention to significant figures. Notice how, since everything here, we've got 3 sig figs here, we've got 4 here, that's why I have that 0.190, all right? And everything here would therefore have that 3 significant figures as well, all right? So this number right here, remember, that is our theoretical yield, all right? Which means that is the maximum amount of the product we could make, all right? What this process, what this question asks us to do eventually is to calculate a percent yield, because this is it gives us the actual yield that we have. Okay, so again, this number right here, that is our experimental, it's also, sometimes called an actual yield. All right, we have that. We now have our theoretical yield, and our percent yield is going to be a comparison of what we did make compared to what we could have made. All right, so this is the formula right here. It's actual yield divided by theoretical yield times 100%. We are going to take that and just plug those numbers in here, and you end up getting 36.8%. All right, so literally what that would mean about this particular reaction is it wasn't really that efficient. All right, we could have made this much right here, but we made less than 50% of what we could have made. All right, so if you were a chemical engineer and you did this calculation, that would mean you need to go back and try some new things. All right, you really don't want to be wasting that much of your starting materials. All right, so hopefully that makes sense, and that's it for this video.